Seeing a lot of cloud material this evening. Skies have a lot of convective debris from stuff earlier. And a beautiful sunset, though. We get some awesome sunsets here in Texas. The only thing that would make this a little more realistic, picture mosquitoes swarming around you. We've got a lot of them out there. As far as the clouds, this is where they have come from. Got a little bit of an active sea breeze right there along the coast. But these storms did not progress very far inland. They got as far north as maybe Centerville, Crockett to maybe south of Temple, east of San Antonio, and then they just fizzled. So not a whole lot driving them, and you can see out there in the Gulf waters, it's pretty clear out there, so things are kind of ramping down just a little bit here in Texas. But there are changes on the way. In fact, we can just scroll some of this north and you can get an idea what's coming. Look at that. This is a new frontal system coming into the Central Plains. And we can see it up to the north here on this SPC mesoscale analysis. We've got these low pressure centers right here north of Enid, and there's another one north of Childress, Texas. And that kind of marks the location of a front coming down through the Central Plains. Ahead of that, we've got typical southerly flow driven by the Bermuda High, bringing moisture northward. But things are mostly up in the Central Plains, so let's switch sectors. We'll bring up the current panels for the Midwest. And you can see some storms coming together west of Indianapolis, north of Evansville into the St. Louis area, and more back here from La Crosse down to Des Moines and Wichita. And these are all out ahead of that front. See right here, you can kind of trace, you can kind of place this in the troughs, and that'll give you kind of a rough indication where that is. And we do have this activity out ahead of it, so we've probably got some destabilization ahead of the front. Here's the Weather Service advisories and watches and forecasts. This yellow right here, this is a tornado watch for western Indiana and eastern Illinois. We've got a couple flood watches through Missouri and into the Wichita area. And again, that's along and ahead of that front coming out of the Central Plains. Can pull up this tornado watch and take a closer look at that. There it is, covering Indianapolis up to Champaign, Illinois, and all the way down to, I guess, I don't know too many of the stations here, I guess Mattoon and Effingham maybe. I've got GR level 2 up, and this is the main storm of the day right here coming down Interstate 74. So that's going to be a little ways northwest of Indianapolis. This has had a confirmed tornado on it for a while. You can see the heavier shading around this warning box. And I'll bring up the panel here that shows the warning in effect. Okay, they've got a canceled tornado warning, then previous tornado warning earlier, radar indicated, and then they've had some spotters out that have actually seen this thing on the ground. So let's zoom in and check that out. The main thing is we don't see classic signatures of a supercell. You can see the core of the storm pretty well in the center of the lower reflectivities. So at first glance, it's kind of multicellular. We'll take a look at the velocity fields. And keep in mind we're pretty far from the radar. We're looking at the Springfield radar, so we're up at about 10,000 feet. See here on the bottom, there's this readout of cursor position. So the lowest tilt is up at about 10,000 feet. And I think we are coming kind of in range of the Indianapolis radar, so if I had more time, I would have put that up. Storm relative velocity, Picking up this little core here of looks like a weak inbound, and looks like some the velocities overall, they don't look too strong. Here we got some 40 knots outbound. See that right there? This really isn't the ideal color scheme. I need to change the palette on this because this color is kind of bad. I know one of our viewers, they sent me a link. I forgot exactly who that was, but they sent me a list of color palettes, and maybe tomorrow we'll install those, and I'll show you how to put those in GR2 and get those going. But looking at this, it looks like this right here is the core of the main outbound. See that right there? And I set the cursor over that, and I'm seeing 50 knots outbound. And up here, I'm seeing very weak inbound. Only about 0. So what I really need to do is come up here and set the storm relative vector. So I'll do that real quick. Let me just put in 250 at 20. And by doing that, we'll see the velocities balance. Let's try to get that out. Balancing out a lot better. So now you can really see that. Here's the main outbound, and here's the main inbound. And that forms a rotational couplet here. So we've got mid-level rotation. We're looking at shear of about maybe 50 knots. So that's a little bit on the marginal side. And it's a very broad rotation. See, I put the marker here, and I put the cursor here, and I'm seeing a diameter of about 4 miles. See right down here? Getting a readout of about 4 miles diameter. So that's definitely in mesocyclone territory. Now maybe if we were a little bit closer, we could get a lower tilt and get really underneath the storm and maybe see some good gate-to-gate shear, but there's no evidence of that right now. So this looks like just kind of a maybe weak supercell, marginal line multicell, and it's continuing to move to the east-northeast here. So let's see here. I was going to pull up. Oh yeah, let me show you this real quick. I've got Rayob here, and we can take a quick look at a sounding for the air mass where that storm developed. This is the Lincoln radio sonde for this morning. And the big thing that we notice here, oh, I made that mistake again. If I'm in Rayob and I hit escape to start drawing, it really messes things up. So let me see if I can pull that up here. Okay, there we go. Okay, so I'm just going to have to kind of point and get through this. But you see this layer right here, how it leans very sharply to the left? That's an unstable layer right there. Very steep lapse rates. So that's going to be pretty conducive to severe weather formation. That and the good moisture we have here in the lowest 4,000. So if I was to draw a lifted parcel, it would probably follow pretty close to this moist adiabat right here. And that's going to give us some pretty good cape. And the other big thing that I notice is the hodograph. When you look at these hodographs, you want to kind of tie this in with the wind plots and make sure that everything is consistent with one another. And we're seeing southeast winds here of about 10 knots, becoming southwesterly up at about 4,000 feet, becoming southeasterly again. So does that match up with this? Yep, southeast here, and as we go higher, southwesterly. So we're getting that southwest flow, and then it becomes southeasterly. And the big thing that I'm noticing right here is if we paint out the storm relative, or the storm vectors, we get this one here for non-severe, and we get this vector for a severe storm. And the important thing is that does sweep out some helicity in this area. And I'm sorry I can't draw with this, but that's just kind of a limitation of the software. But we do have some decent low-level shear in place, and we would, of course, want to modify that and see if that situation changes during the day. That might be a good topic for an upcoming forecast segment. But But let's look at the forecast right here for the next week. Here you can see this very meridional flow right here. The strongest flow we have is up in eastern Canada. But we've got more waves upstream and another one out in the Bering Sea. So next system comes down on early next week. And that deepens and we get this cutoff flow off California. So that'll be the main story early next week. Then we get into kind of a split flow pattern. We get the subtropical jet, maybe a polar jet going here, northerly channel up there. And then as you get really far out to 240, 300 hours, look at this ridge develop here. Big, large wavelength ridge right here with this deep northwesterly flow across the U.S. If this was December and January, we would be talking Arctic outbreak for sure. This time of the year, we're probably just going to kick down a very cold polar air mass. So we're looking at about September 22nd. And this is about 300 hours out, so this could definitely change, but look how much even more severe it gets if I move this forward. See, now it gets even more high amplitude, and we start developing some stronger flow. Look at that. So we'd be in a big-time winter situation if it was around the holidays. That's like the Siberian Express right there. So if that happens, the last part of this month could get rather interesting. How certain are we of that? Well, I'm going to show you a little bit about ensemble models, and I'm going to go to the Canadian website. You can see this URL, and if you miss it, you can run the playback of this weathercast and grab that. But they've got a fairly decent weather page. They don't have all the products, but they've got a few things here we can look at. So let's bring up the 500 millibar heights. This is the ensemble. And when we talk about ensembles, the thing is that these models can be run so quickly with today's computer power, it makes sense to just kind of change the physics a little bit and change the parameters and run it again. And run another model and run another and see how consistent they look. Okay, so here we're looking at the 582 decameter height line. And up north we have a 522. So we're looking at lines for different iterations of that model, and we call this a spaghetti plot. So we're looking at the 0-hour forecast. Let me shrink this down so you can see a little bit better. There, how's that? It's a little bit better. The important thing is you can see the time here, and right there is the forecast hour. Okay, let's run this forward. So here you can see this trough over the northern Rockies. And you're going to watch as these spaghetti plots start to diverge. See, the first place that happens is over the Midwest. So this right here is where we're starting to look at the forecast going out to lunch. So we're only 36 hours out. So we continue to run this forward. Things are looking pretty good, especially on the West Coast, so we can be fairly confident of the forecasts out in that area. So things are starting to come apart a little bit at 84 hours. Look up north at this. So you can see that the weaker data field up there has added even more uncertainty to the forecast up there. So let me set this back. We're at 84 hours. Run this forward a little bit more. So now we're starting to see different solutions for that cutoff flow that I mentioned earlier off the California coast. 108 hours, September 14th and 15th. Things are looking pretty crazy out here in the Pacific. So we don't know exactly how things are going to pan out for the western U.S., but things are still pretty much on track for the East Coast. And so we continue this forward. Now we're out at 168 hours, 180, and this is where we're starting to really get into sketchy territory. So a lot of different solutions here for the western U.S., and about all you can do at this point is look for the best consistency for the forecast for then. So let me see how far we can get out here, because I think this may pick up a little bit on that massive ridging later in the month. We can see how certain we are about that. So we should start to see the ridging forming out here. It was mostly the GFS that was picking that up. I wonder if the Canadian model is going for that. I don't know. It's hard to tell. I think what we need is another contour in the middle, and we don't quite have that. But I do see a couple of ridge lines. There's one there, but yeah, you know, this is pretty far out, so there is going to be quite a bit of uncertainty as far as that goes. So we should also look to the south. Let's check out what's happening in the tropics. Looks pretty clear in the central Gulf. Maybe one little weak wave through here. Here's another big one moving through the Bahamas and Cuba. But things are pretty dry out in the Caribbean. So we continue moving out west. Here's one little wave. And then look at this. Here's a rather large system in the almost to the middle of the Atlantic. So this is going to be north of Brazil. And then finally we get to the African coast. Here comes another wave coming off the coast there. And more stuff. This could be one of our future hurricanes in a couple weeks. It's always kind of neat to zoom in down there and see these massive storms coming together in Mali and the Ivory Coast. I wonder if you could actually do any chasing out there. Really beautiful towers out there. Then, of course, as you move into the Sahara Desert, you get a lot less of that. But sometimes these storms will develop pretty far north and kick up a lot of dust, and that will go as far as the United States. And when that happens, we get some hazy conditions here. So here's the NHC forecast. And one thing very notable about today, this is the peak hurricane, or the peak tropical storm time of the year, September 9th. So that's pretty noteworthy. And it's also the peak of sea surface temperature out in the Caribbean and the Gulf of Mexico. So this is the ideal time for something to come together, and that'll kind of be the case over the next several weeks, and by late October we'll see the chance of tropical storms start to diminish quite a bit. So we're seeing this one here, remember that wave that we had just north of Brazil? Looks like pretty strong signals for recurvature on that, so that may not be in the forecast picture. And of course we'll have to keep an eye on this thing that's north of Puerto Rico. And nothing obvious coming off the Atlantic or the African coast here. And just a very quick look at the Atlantic. Let's run through this really quickly, looking at precipitable water and pressure. This is the circulation they're looking at for possible hurricane development. And you can see that recurve to the north. Looks like it goes east of Bermuda. Then we have this next system coming off the African coast. That looks like that recurves also. So it looks like we're going to be kind of quiet in the Gulf of Mexico for the next maybe week and a half. Don't see anything going on out there. It's like our next wave comes across the Cape Verde Islands about September 18th. That may be a little bit on the north side, though. We'll just kind of have to watch that. So it looks like our main weather makers are going to be coming from the northwest over the next several days. Okay, let's see. Peak of fall, or I'm sorry, fall is going to start on the 22nd, so we're only about 12 days away from that. And that's the time of the equinox, so the days are starting to get shorter, and the nights are getting longer than the daytime hours. That's the big thing about fall here. So should be fun as we get into these outbreaks over the next couple weeks. Should have a lot to look at, and we'll definitely get into those baroclinic systems and talk more about the structure and maybe learn a little bit about that. Okay, let's see here. I think that's about all I got, guys. So I appreciate you watching, and I'll see you tomorrow afternoon or tomorrow evening, same time, 8 o'clock. Thanks.